Number 3, Charles writes 7 to the 5th power times 3 squared equals 21 to the 7th power, and the teacher marked it wrong. Explain Charles's error. So in short, Charles is wrong because he would need to have like bases in order to apply the rules of exponents. Charles can only apply the rules of exponents if he uses the same base the whole time. If that makes sense to you, great. But let's look at a little more why this is true. Let's actually work with the right-hand side of the equation and work backwards to the left-hand side. So the right-hand side of the equation says 21 to the 7th power. So in other words, 3 to the 7th, 3 times 7 instead of 21. So 3 times 7 to the 7th power. So all I did there was I changed this 21 to 3 times 7 because they're equivalent. So in other words, this means 3 to the 7th power times 7 to the 7th power. So if I think about what this means that I'm taking 3 times itself 7 times, times 7 times itself 7 times. That's what the right-hand side of this equation looks like. Let's take a look at the left-hand side of this equation. The left-hand side of this equation originally said 7 to the 5th power times 3 squared. So if we were to map out what this looks like, first of all, we can tell just by looking at these powers here compared to what I just wrote that these do not mean the same thing. So 7 to the 5th power times 3 squared, that's going to give us 7 times itself 5 times 3 times itself 2 times. So if you take a look at what's up here, what 21 to the 7th is equal to, it should be fairly obvious that 7 to the 5th times 3 squared does not give you the same thing. So that's why Charles can only apply those rules if the same base is used the whole time. Otherwise, the rules don't make any sense. It doesn't make sense to just add those powers without having a reason to.